Hey guys, welcome to part 3 of this tutorial where I show you how to code Google's Dino game. So in the last video we added our Dino character, so let me show you. We make him give the illusion that he's running, and we also coded the jumping physics. So we have a pretty good chunk of our code, of our game. In this video we are gonna be coding the obstacles of the game. So in this case, I will be coding just the ground obstacles, so the cactus. I'm not gonna be coding the birds because I didn't find the texture for the birds. But you can try finding some similar texture as the one of the birds and try adding it to the game, because the logic should be the same logic for the cactus and for the birds. But yeah, as I told you, we're just gonna be coding the cactus. So yeah, we're gonna be creating a new class cactus. We're gonna be adding some properties to it and some methods, and if we have some time we are gonna be coding the collisions between the Dino and the obstacles. If not, we're gonna be doing that in the next video. So yep, let's start coding. Okay, so we're gonna start by creating the new class, the cactus class, but before that, I'm gonna copy the Dino class and I'm gonna paste it below the background class. So in between the game class and the background class, this is just the structure of our code, but yeah, it shouldn't affect the result of the game. Okay, so we're gonna be coding the cactus class right here in between the game class and the Dino class. So go ahead and type class cactus. Let's add our init method and we're gonna pass it for now. So remember, we have 3 methods that we want to repeat on basically all of our classes, and these are update, we're gonna receive self. Okay, let's add our show method, self as param, and let's add our set texture method. These are gonna be the 3 methods of the cactus class. We don't need any more methods because when we start coding the collisions, we're actually going to have a new class called class collision, and we're gonna be doing the logic inside that class. Okay, so let's start by adding some properties. So as always, we have a width. This is going to be 34 and the height is going to be 44, the same as our Dino. Let's also add a self.x, and this is going to be actually a parameter because we want to start moving our cactus. We're gonna start moving our x coordinate. The y coordinate is not gonna change, so we can hard code this value and we're gonna set it equal to 80. So it's basically the same self.y as the one of our Dino right here. And then we can call our set texture method and our show method. So okay, let's start by creating or coding the set texture method. So I'm actually going to copy the background code. I'm gonna paste it here because it's pretty much the same, but we're gonna change the path. So instead of background, we're gonna put a cactus. Now show method is also going to be the same as the one of our background or of our Dino. So go ahead and copy and paste it. So it's basically a screen.bleed. We want to bleed the texture that we already created, and we want to bleed it on a specific location on screen. Okay, an update. So this is pretty simple also. We're gonna receive a dx and we wanna set our self.x property. We want to add to our self.x property that dx param. So this is going to be a negative value to make the illusion that the cactus, it's moving to the left of the screen. This is pretty much the code or the same code that we have on our background class. As you can see, self.x plus equals dx. So pretty simple. Let's go to our main loop, and after we show our Dino object, we want to show our obstacles. So Cactus. So right here we need to create them actually. So here in game we can actually add a new property, and this is going to be Cactus, and it's gonna be equal to a new Cactus. We need to send an X. The X is going to be random, but for now let's code it, let's hard code it, and let's put something like, I don't know, 300. So X equals 300. Yep. So right here we can do something like Cactus. Game.cactus. So game.cactus.show, and we want to update it also. So game.cactus.update. We want to update it well before we show it, and we want to update it, remember, with a dx of minus game.speed. So same speed as we did with our background. So this should be pretty familiar to you. Yeah, I think this should work now. I'm gonna save the file and run it. So as you can see, we have our Cactus. I'm gonna actually run it again for you to see. Obviously we haven't coded the collisions, but as you can see, we have our Cactus working. Now we have a problem, and this is the challenging part of this video, and it's that we need to, first of all, we need to have a list of obstacles. We don't want just one obstacle, we want a list of obstacles, or in this case of Cactus. The second thing is the following: we need to somehow randomly spawn our Cactus on screen, because as you can see, we're spawning our Cactus, our only Cactus, in a position of x equals 300. We need to make these to be random, right? So okay, let's start by creating actually an array list, or a list of obstacles, and this is going to be a list. Now we can delete this line of code, the self.cactus line of code, and inside of our main function, instead of showing one Cactus, well, we're gonna loop. So for Cactus in game.obstacles, we wanna do the following. So we're gonna update the Cactus and we wanna show it. Now this is pretty similar to the background code. It's actually the same, right? Because both objects are actually a list. So let's actually start populating or adding Cactus to our obstacles list, and we're gonna do this inside of our game class. So we're gonna have a method. We're gonna have two methods for now. One is gonna be called toSpawn, and this is going to be responsible of telling us if it's time to spawn a new Cactus. We're also gonna be coding a spawn Cactus method. We're gonna receive self as parameter, and yeah, this is going to be responsible of actually appending or spawning a new Cactus inside of our obstacles list. Yeah, we're gonna start with this method. We want to randomly spawn Cactus on screen, but it cannot be fully random. Why? Because we cannot have, I don't know, two Cactus which distance in between is so small that our Dino cannot jump it. So we need to somehow implement a logic, and we're gonna be doing this by knowing the position of the previous Cactus. I don't know if I'm even clear, but it should make sense when we start coding it. So yeah, we have two options. The first one, I'm gonna put a comment, is when we have our list with cactus. So we already have added some cactus. This is the first option. So it's basically going to be something like if self.obstacles, if len of self.obstacles is actually greater than 0, we're gonna do something, else empty list. So else we're gonna do another thing, and outside, so right here, we wanna, well, create the new cactus. Okay, so let's start with the empty list. So what happens when we don't have any cactus on our obstacles list? So this is going to be pretty simple. We are going to create an X for our cactus, and this is going to be random. We actually need to, I'm gonna auto import this, but you need to import, let me actually edit this. We need to import random on top of our file. So right here, random X is gonna be equal to random.randint. Okay, so the first parameter is going to be width plus 100, for example. So we're basically saying, okay, generate a new X coordinate between the width plus 100 pixels and, I don't know, something like 1000 pixels. You can play with this. These are not like exact values. You can use your own values. But yeah, it works for me. And once we have created our X variable, we're going to create a new cactus. So right here, cactus is going to be equal to a new cactus, and which X is going to be equal to this X. Or you can just, well, pass the X parameter. And then the last thing you want to do is, well, type self.obstacles.append our new cactus. So we're basically appending our new cactus object. Now, this is easier than this if statement that we haven't coded. Why? Because the first cactus, we can literally spawn it wherever we want, because we don't have to check if it's being spawned too close of another cactus, right? So this is actually easy. I'm gonna actually run the file and I'm gonna show you well, the result. So let's see. Let's hope for it to, oh, so we didn't call the function. So let's see. Where is it? Right here. So right here, I'm gonna just spawn one cactus. So if loops equals 0, no, I'm sorry, equals 1, we're gonna call the game dot spawn cactus. Yeah, this is not part of our code. I'm just showing you that it actually works. So yeah, as you can see, it spawned right there. But if you run it again, it's going to spawn in a different position. You cannot see the position, the exact position, but it's actually doing random positions. Okay, so it's working correctly. Now we can continue with our code. So as I was telling you, this if statement is a little bit more complicated because we need to know the previous cactus position. So let's start coding it. We're gonna start by typing or by creating a new variable called prev cactus, and this is going to be equal to self.obstacles in the position -1. So we're basically taking the last object or the last item of our obstacles list, and this is going to be the same as the previous cactus that we spawned. Now, I think you can see why we need an if else. For this because for the first cactus we actually don't have items, so we can't do this line of code. Okay, we're gonna type, or we're gonna create our x variable here, and this is going to be random.randint. The initial position, it's going to be our pref cactus dot x plus 44 plus 84. So yeah, you can do this addition, but I like to explicitly show these two values. Why? Let me explain. So we're basically telling the program, okay, we're going to return a random between the previous cactus x plus 44 pixels, and these 44 pixels is actually the width of our Dino. So we're basically making sure that in between two cactus, our Dino is able to fit, right? So this is the 44 pixels. Now 84 pixels, I think is just a random value that I put, because we need to add some space, some more space. If we let it with the 44 pixels, I think it's impossible for our Dino to actually jump in between two cactus without dying. So we need to leave some more space. So that's the first param, and the second param is going to be the width of our screen plus the previous cactus x plus 44 pixels plus 84 pixels. So the same thing that we did here. So yeah, I think this method is completed. Now we need to do the spawn, or the toSpawn method. So I want you to see, remember what we did with the inside the Dino class with the walking if statement, that we use the loops in order to check if we need to walk. We're gonna do something similar to check if we need to spawn a cactus. So we're gonna receive loops as parameter, and we're gonna return loops module 100 equals 0. So the same logic as the one we did inside the Dino class. We are just spawning the cactus when our loops reach a multiple of 100. Remember, you can play with this number. So for me, I'm gonna use 100. And right here, let me see, inside of our cactus section, inside of our main function, we want to see if the game.toSpawn, we're sending our loops. So if it's time to spawn a new cactus, well, we're going to actually call the game.spawn cactus method. So like this. And then we want to show it. So yeah, I think this should work. So yeah, I'm gonna run the file to see if it actually works. So yeah, we should see a lot of cactus being spawned. So yeah, as you can see, we have a lot of cactus being spawned, and this is pretty cool because the distance between the cactus is totally random, but also it's making sure that the distance, well, that our Dino is able to fit inside of that distance. So we're not gonna have impossible situations in our game. So yeah, pretty cool. We haven't coded the collisions, but yeah, we pretty much have the code. We have the cactus being spawned in our game. Okay, so we're gonna be coding the collisions in the next video because I don't want this video to be so long. But before we end this video, I want to actually add another thing. This is pretty simple, so don't worry. I think it's right here. So instead of adding or of hard coding 44, we can actually do the following. So self dot Dino dot width, and also here. So self dot Dino dot width So yeah, we are replacing the 44 with the actual Dino width, which is actually the same, and it is what we want. We want the width to be here. And this is a hard-coded value that you can play with it if you want. So yeah, this is all for this video. In the next video, we are gonna be coding the collisions between the Dino and the Cactus. So yeah, I hope you liked this video, and thanks for watching.